Google Vice President of Product Management for Google Cloud Platform, Sam Ramji.
Good afternoon. One of the things we were kidding around about backstage on was, can you imagine 6,000 people who all came here to pay for free software? Isn't that awesome? Give yourselves a hand. No, seriously, we're incredibly grateful because sustainability and openness comes from contribution in multiple forms. Contributing code, contributing goodwill, contributing revenue so that developers can get paid. It's fantastic. It's a much friendlier audience than I had last time I was here, which was in 2006 at LinuxCon. Anybody go to LinuxCon back then? Oh, okay, well, rest in peace, LinuxCon. At that time, I was running Linux and open source for Microsoft. Now, it wasn't that popular there either, but over time, we did reform the company's practices, and by 2009, my team contributed virtualization technology to the Linux kernel under the GPL. In fact, for a few releases, Microsoft was one of the top contributors of code to the Linux kernel. Fast forward to today, and I have the privilege of being Vice President of Product Management for Google Cloud Platform, a company to which open source is no joke, and it's in fact built into the core of how we think about cloud as well as core computing. So let me take you through that for the next few minutes. We actually think that this is the best time in history to be a developer, largely because every company needs us in order to transform their business, right? So our craft is respected, our work has been elevated, and we're in an era of rising demand, right? This is our time. But as much as it's our time, the stakes are also high. We have a responsibility to our craft, to each other, that developers never had before. And high among those is the need to create systems that are not just secure and flexible, but open. Open so that we can shape them the way that they need to be. So we believe at Google we're entering an age of open development. Openness is by no means a new concept. It was a key design principle for the internet. So back in 1994, for the record, I was 2.5 when this paper was published in IEEE. Vint Cerf, who I now amazingly get to work with at Google, he's a vice president in our firm, keeping us honest and accountable for our open strategy. He and Bob Kahn published this description of the internet, and according to Vint, it was by design that everything was free, the intellectual property was free in order to create mass innovation, and most importantly, his term, permissionless innovation. You shouldn't have to ask permission to build on top of the internet protocol. You shouldn't have to ask permission to build below it. You should just be able to use it, embed it in an endpoint, and look at the world we have today. So we owe a great amount of respect and appreciation to Vint and Bob for their insight, but it's no less important to the open cloud today. Permissionless innovation is something to keep in your mind. So for the past 30 years, openness has really become the standard in the developer community. It's how our software is licensed. It's how we expect our tools to be standardized. In construction, you had a 2x4. Where are those types of standards for software? You find them in open source libraries. And that's because open source and collaborative work is a positive-sum game. Everyone gains. We've seen it become the dominant form, not just of technology, but of business. There's research from many universities, MIT, Stanford, Berkeley, and others, showing that, in fact, in order to innovate better and faster, technology development needs to be inclusive and collaborative. We know that open businesses grow faster and are more profitable because there's no one organization that can innovate as quickly as an open community, right? All of us are smarter than any one of us. So we are actively participating in this collective innovation at Google, and I'd like to talk to you about a few of the things that we've done in the last decade and then some of the things we've done in the last year. So for the last 10 years, we've been very intentional, starting with contributions to Linux in the form of containers. Back in 2007, as we were scaling Google's massive infrastructure, where today we have 8 different businesses that have 1 billion users each, all running on Linux, we knew that we had to have a scalable way of running Linux at speed and at high reliability. So we looked at C groups, namespaces, things that we now call containers. We built an internal system called Borg, which I'll talk about in a moment. Contributed to Python, to Git, to many others. More recently, it's become hard to count. So in the last year, Google employees contributed over 287,000 commits to open source projects. That's 15,000 projects and over 2,500 projects where we were highly engaged with more than 10 commits. So the frame that we're occupying for open development is this idea of a simple formula, right? Open source, that's a given, right? You may or may not be here at this conference because you care a great deal about open source, but you're definitely using Red Hat Enterprise Linux because open source works incredibly well. It grows fast. Think about Linux in 1997. It was not a serious competitor to HPUX or Solaris, but you just advance the clock a few years and you start to see that rate of innovation cycle up, and you get to today where Linux is really the only choice. So we believe that you need to not just accept open source, but also to give back to it. With open APIs, we think it's important to be able to access those services from anywhere in the world, right? Not just locked down from a single provider's environment, but be able to move your code around to any cloud, to any environment that you might like to run your software in. When we have access to every part of our technology environment, we can build the systems we require to develop at the speed we need. And finally, open cloud itself is a core part of keeping our broader development ecosystem open. I'll talk more about that in detail. We think there are 3 core tenets to the open cloud. Now, why is it so important to build open source? Why is it so important to use open APIs and build on open clouds? One of my favorite books is called A Fire Upon the Deep, and that's by Werner Vinge. Don't know how many people here are science fiction buffs, but it's a story about the far future, tens of thousands of years from now, where you have interstellar travel but no light speed. So everybody sits in cold sleep, and you have programmers and people who come on shift fixing the ship, fixing the systems, building new software. But you can imagine that the really old software, the really old boring systems like life support, run really old code. So there was a title in that book that captured my imagination, and I think we should think about this name as we think about, should we build our systems open or closed? Should we have empathy for the people coming after us? The title is Programmer Archaeologist. Anybody here ever done any programming archaeology? Was it fun? Did the people who built the systems before you anticipate that you would come and use what they're building? Now, keep this in mind. Whatever we build today is tomorrow's legacy. So openness matters even more now as we start to trust all these things to cloud providers that you have to hold accountable. So if you have empathy for developers, if you have empathy for yourselves, if you take your responsibility seriously, then you want to be able to build your systems in a way that's portable, that you can run anywhere. Chris and I will talk about this a little bit later. But Kubernetes is an example for us of open source driving both innovation and business. Google developed Kubernetes based on our internal Borg tool. But since releasing it to the open source community through the Linux Foundation, we've seen engagement and adoption skyrocket. More than 4,000 projects based on Kubernetes, 43,000 commits, and over 400 years of work have been put into Kubernetes just in the last few years. So Kubernetes now has roughly the same adoption momentum that we saw in Linux. And all of this is because of community. It's important for me to emphasize that. Open source is not about the code. It's about the community that uses, participates, gives back, criticizes, documents, and popularizes a project. That's how open source stays alive and is relevant. We're incredibly proud of the fact that there is more Kubernetes running outside of Google than there is inside of Google. And to be clear, we use a lot of Kubernetes internally. TensorFlow is another great example of open innovation. Anybody here heard of TensorFlow? Okay. This project is absolutely on fire. We believe in the democratization of AI, and to do that, we wanted to make AI accessible by everyone. So we released TensorFlow, which is an open source ML library. But its pragmatic altruism was also very good for us. 3 or 4 years ago, at Google, we had a set of proprietary, internal-only ML libraries. We didn't get a lot of adoption, right? We opened it up, and now today we're using 4,000 different machine learning models powering everyday Google technologies that you rely on, like Gmail, search, and ads, just making products a little bit better. TensorFlow can and is being used by researchers and companies, and it can run on CPUs, GPUs, or anything that you choose to run on. Think about the IoT at the edge device that was just described by Sandra, right? TensorFlow is refined enough that it can run there. You can push it up to the cloud, where you can train a model on the elastic resources, elastic compute, elastic storage, very fast networking. You can pull the trained model all the way down to the edge and run it on very small devices, because the trained model is like a fingerprint as opposed to the whole person. So you can carry that intelligence around with you. This is going to be a crucial project for development of AI, but most importantly, AI writ large will just seep into everything that we do, just make each interaction a little bit better, make your experiences smoother and more sensible. What we say at Google is we should make sure that we wrap software around the human rather than forcing humans to be wrapped around the software. And again, the open source community has contributed phenomenally to this project. 475 non-Googler contributors, 14,000 commits in just a year. And TensorFlow is the #1 machine learning repository on GitHub and is becoming a de facto standard for machine learning across the industry. It's being used in companies, it's being used in large and small, hobbyists and startups, because open innovation requires a very low bar, right? The barriers to access should be as close to zero as possible, so we can invite as many people in to use it and to make it better. I mentioned open cloud has a strict definition in our view. So we think it's these three things. We think it's open source, open access, and an open ecosystem. So open source we've beaten to death probably at this point, but open source obviously is something that we contribute to, we participate in, we operate. There's a ton of open source running Google's services today. In fact, I would argue that we couldn't have built this company if we were constantly having somebody else fix the software or if we had to pay license fees. Probably wouldn't have been economically viable to operate Google. With open access, we believe you have to have no barriers to entry or exit. Things that you run in the cloud should be just as personal and just as well owned as things that are in your own data center or on your own server. There should be no restrictions. And finally, an open ecosystem. I think services built by communities and companies should all get the same representation and distribution as services built by the cloud provider. Our implementation of Cassandra or Postgres or Linux is not necessarily the best one. You should be able to run whatever you want, and you should be able to find services built by third parties that have every advantage that the cloud provider has. So ultimately, users win in an open cloud. We believe that technology moves forward in great leaps from time to time. The cloud is one area where there's been a great leap forward. It's our job to make sure that you hold high standards, that you hold providers like us accountable for openness. And in fact, the reason that I came to Google was a conversation with Brian Stevens, previously CTO of Red Hat. Many of you here may have heard him speak or met him in person. When he came to Google, he came with a simple strategy to build the open cloud. And when I heard that, my imagination was seized, and I thought there was no better place we could possibly deliver on the promise that open source holds for the next generation of innovation. So with that, let me welcome a very special guest who will talk with me about making the open hybrid cloud real. Please welcome Chris Wright, Red Hat Vice President, Chief Technologist. Chris, come on over. So Chris, I have to observe that you are not Kelsey Hightower.
Point well taken. So it turns out Kelsey and I both live in Portland, Oregon, and there was a little mix-up in the airlines. I got his seat, and he's home, so I have him watching my kids. Kelsey, if you're watching, we're sorry you're not here, but I think we'll have a great time.
Well, that's an open community for you. So Chris and I both have the privilege of sitting on the governance board of the Cloud Native Computing Foundation, work on Kubernetes together. We actually met many years ago at LinuxCon Cloud Open in San Diego, where I saw you talking from afar, and I thought, my God, I have to go and meet this person, one of the smartest people I've ever met. What I was hoping we could do is make transparent to you what we mean when we talk about open hybrid cloud. So any opening thoughts?
Well, you've heard a lot about our view on open hybrid cloud from Paul this morning, and it's something we'll keep talking about. I think a big part of that is enabling our users, our customers, to create an environment for themselves where applications are portable across infrastructure. And it's something that we're really familiar with in terms of application portability. It's just that today, the platforms that we're using are clouds, not traditional physical servers.
Yeah, one of the things that often surprises people is that Google's point of view is that the long-term structure for computing is, in fact, hybrid, much like electricity. Now, when I say that, people say, but electricity is all in utilities, right? There's no need for a chief electrical officer anymore. Nobody worries about that. And I kind of come back and say, well, how many generators do you think are in this building right now? So as much as electricity is a well-structured utility, we still need it all over the place. So we're going to be computing for a very, very long time in this distributed fashion where you have multiple clouds, multiple data centers, and you need to be able to move compute around, which kind of brings us to containers.
Well, and with that, we have an application platform today is trying to allow applications to span and scale across a data center infrastructure. So what from a Red Hat point of view, a lot of the work that we've done in the past is focused on enabling a piece of hardware with Linux as an abstraction for the application. And even higher level abstractions with things like Java and other runtime environments. Today, Kubernetes is helping us build that same conceptual abstraction where the platform is no longer a single server, it's a data center. It's a big piece of infrastructure. And we're giving that same application orchestration point of view. How do we build applications that take advantage of that whole data center with a standardized platform? And for us, that's Kubernetes, and it's a great project that we've been working on together, Google and Red Hat.
It's true. Yeah, and thanks to you and thanks to Red Hat for convincing us to open contributions up broadly, right, to everybody, and not just kind of having read-only open source, right? It's transformed, I think, the project, and hopefully it'll transform cloud computing.
I think one thing that we've learned is, as you give things away, as you give away some of your control, you gain a lot. And there's that reticence, especially in the beginning. You feel like you need to hold on and manage control, but it turns out taking on broad-scale contributions is what really makes a community thrive and what allows technology to progress, and it's brought us to where we are today.
Well, it's been symbiotic for the project, right? Because if we were just building Kubernetes inside our sort of Google data center clean room, there's a lot of concerns of sort of day-to-day enterprises that we would never be able to never be exposed to. But that's stuff that you're in every day, right? So we've been able to learn from you as you've taken this out to the reality of security and policy and all the things that you have to do to get things into production.
Yeah, that's right. The enterprise is, I sometimes like to call it a special snowflake. There's so many different potential combinations of technologies. And you go to an enterprise, you'll find every possible combination. Web scale is a different view, and that's really about consistency, standardization, building things at pod scale or rack scale or data center scale. And so the enterprise is also learning from our web scale companies to help us understand what standardization looks like, how we can use automation to improve our efficiency. And really, I mean, the end game here is getting applications running as quickly as possible so that you can address the business realities that we live in today, which is a very quickly and dynamically changing environment.
Well, when you and I started collaborating most recently, it was a little over a year ago at the Linux Foundation Summit. I was CEO of Cloud Foundry, and we had a pretty rich services environment, like lots of services plugging into the service broker. Craig McLucky started talking about, hey, that's a really nice broker. I said, hey, what if we offered it to you all? What if we could all collaborate on this one sort of big open service broker interface that you could wrap anything you have in a standard API and then use any service from anywhere, wherever you happen to be running your containers. And kind of fast forward a year, it seems to be working.
This is the power of community and collaboration, where started with an idea. We were in Tahoe and looking at what do we need to do for enabling a modern application is a collection of services. And these services are some in-house written services, and some are platform-specific services. Some are services external to your platform. It could be software as a service. It could be that database server that's still running on bare metal, hasn't even been virtualized yet. That combined, composed or aggregated is your application. And building the service broker is a mechanism for creating consistency. Independent of where you're running, you always have access to these services, assuming you don't have VPNs or anything like that in the way.
Yeah, and especially if you do it in a standard way. So one of the things we were talking about before was what are our mechanisms for trust and sharing, right? So open source foundations, some serve a role trying to create standards like OCI, some serve a role of enabling sort of collaboration and practice. You're on the board of the OCI, of the CNCF, and you participate in the OCI. People might be interested in sort of the distinction between the two.
Well, I think, first of all, there's an interesting place where we are in the industry today, which is we've come a long way, and VentSurf really helped a lot of this. We've come a long way with traditional standards. Standards and open source are evolving together, and something like OCI gives us a place where we can use open source and the open source collaborative model to create consistent container runtime and image formats that will run independent of your orchestration platform. That's something that's really important for the industry. We're leveraging that in the CNCF, where we're collecting a whole set of cloud-native innovative technologies, including the flagship project, Kubernetes, combining those together to really help build this this next generation cloud native infrastructure.
Yeah, and it's also holding place for a lot of other things like FluentD and gRPC and Core DNS and things that we find as there are holes in the stack because Kubernetes doesn't do everything. It's a place that we can sort of fill that out. So looking to the future, you've been one of the architects and proponents of federation of Kubernetes clusters, which seems almost like constitutive of an open hybrid cloud, right? Containers running on multiple premises, containers running on multiple clouds, right? Your ability to know what's actually happening, have a common operational stance.
Yeah, I think it's really an important part of where we're going with the Kubernetes community. We need to enable our users to build geographically disparate systems spanning different infrastructures, public and private. Federating is a way to scale in general, even within a single data center. So that's a really important area for us. I think another interesting space for the future and for Kubernetes is helping support what I would call workload-specific optimizations. You were talking about TensorFlow earlier. If you don't have access to GPUs, you're probably not getting the same performance that you're looking for.
Yeah, absolutely. And we might even look at the cloud, when properly built, should be a planetary scale computer. So if you're running Red Hat software, that should just look like a hardware layer to you, right? The drivers should take care of it, and you should get intelligent placement. So if you know that you're running, or the software knows that you're running a TensorFlow workload, it should automatically have affinity to acceleration. Yeah, so distributed systems are hard.
Well, I like to remind people that we are building large-scale distributed systems. If you look at a platform like OpenShift, that's exactly what it is. You look at some of our storage platforms, those are distributed systems. OpenStack, these are all large-scale distributed systems. Our application developers are also building distributed systems as you move into microservices-based software architecture. And some of the challenges there can be intimidating. And one of the things that I think is important for us as community members, platform creators, is to push some of that complexity down into the platform so that application developers can really focus on building applications.
Yeah, awesome. So it's exciting to work with you. We've got a long road ahead. We've got lots more services and service meshes and infrastructure to build.
That's right.
But at least we've got a practice for doing it. So everybody, please thank Chris for joining.
Thank you.
And thank you very much for your time today. I appreciate it. All right, exit right.